Hi, let's review the holidays homework. Okay, so question number one, Blair's write a paragraph about data transmission in her computer science examination. Use the list given to complete Blair's paragraph by inserting the correct 5 missing terms. Not all terms will be used, and terms can be used more than once. So these are the terms, okay? So for example, first term is duplex, then we have half duplex, parallel, serial, and simplex. So what is duplex? In the duplex here, you can see data can be sent from A to B and B to A at the same time. Okay, so for example, the example of duplex data transmission is the phone call. Okay, so both A and B, they can talk at the same time or send data at the same time. Next type of data transmission is called the half duplex. In half duplex, data can be sent from A to B and from B to A, but not at the same time. First, A will send the data to B, and then when A is done sending data, then B will send the data back to A. Okay, so the example of half duplex is the walkie-talkie. Next is the parallel. What is parallel? Parallel is a type of data transmission which uses multiple channels, okay, to transmit the data, and multiple bits can be sent from A to B or B to A. So you can see here is the example of parallel. Okay, in the parallel, we use multiple channels or multiple wires, and multiple bits can be sent at the same time. Next one is the serial. So in the serial data transmission, we use the single channel or single wire to transmit the data. So the bits can be sent one after other from A to B. And the last one is the simplex. In the simplex data transmission, data can be sent from A to B in only in one direction. Okay, so A can send data to B, but B cannot send data back to A. So now you got the idea after different data transmission methods. So now let's fill in the blank. So the first fill in the blank, dash data transmission is when data is transmitted a single bit at a time. So that is the serial. We know that the single bit can be it's transmitted at a time, right? So that is the serial. Next one is dash data transmission is when multiple bits are sent all at once. So that is the parallel. You can see here multiple bits are sent at the same time. So the correct answer is parallel. Next one is if a user wants to transmit data over a long distance with the highest chances of accuracy, dash data transmission should be used. So in the case of long distance and highest accuracy, we should use the serial data transmission. Okay, next one, if data needs to be transmitted in one direction only, for example, from a computer to a printer, dash data transmission should be used. So we know in case of sending data in only one direction, we can use the simplex data transmission, because in the simplex, we can only send data from A to B, but not from B to A. So the correct answer is simplex. Okay, so next is if a user has a large amount of data to transmit and this need to be done as quickly as possible, dash data transmission should be used. So we have serial. Serial uses the single channel to transmit the data, okay, and one bit is sent at a time. But here you can see we have parallel. In the parallel, we have multiple channels and multiple bits can be sent at once. So for this question, the correct answer should be parallel. Okay, so let's move to the next question. Tick to show whether each statement is true or false. So the first statement is both Unicode and ASCII code are example of character set. Yes, that is true. Unicode requires more bits per character. Yes, Unicode requires more bits to store one character. Next one, ASCII can represent a great range of symbols and emojis. No, ASCII can only represent 255 characters, right? Next one is Unicode can represent a great range of different languages. Yes, that is true. Unicode can represent different languages, for example, Chinese, Spanish, or different other languages. 5 statements are given about the error checking methods: checksum, check digit, and the parity check. Okay. Option A is take to show whether each statement applies to checksum, check digit, or the parity check. Some statements may apply to more than one error checking methods. Okay. So first statement is dash uses an additional bit to create an odd or even number of 1. So that is the parity check. Okay. Because in the parity check, we need to create the even or odd number of 1s. Next one is the checks for the error on data entry. So check digit is a method that is used for that is used to check the error for data entry. Number 3 is compares two calculated values to see if an error has occurred. So checksum uses the calculated value and also the check digit. They both these two methods uses the calculated value and compare them to see if there is an error or not. Dash will not detect transposition error. So parity check won't be able to detect the transposition error. So what is mean by the transposition error? So for example, we have a bits, right? 2 or 3 bits. Okay, so this is 0 and this is 1. So for example, if these 2 bits are changed or the change, for example, this 0 become 1 and this 1 become 0. So in this case, the parity bit won't able to detect the error. Okay. And the last option is sends additional values when data is transmitted from a computer to another. So which one send the additional values? So checksum is used during the transmission, right? Check digit is not used in the data transmission, so we'll ignore this one. And the parity check also send the additional values. It send the parity bit, right? So these are the two options which are correct. Let's move to the next question. A computer can have both MAC address and an IP address. 4 statements are given about MAC addresses and IP addresses. Tick to show whether each statement is true or false. So first statement is a MAC address is unique to a computer on a network. So that is true. MAC address is always unique. Next one is once an IP address has been set, it cannot be changed. So that is false. We can change the IP address because we know we have two types of IP addresses, right? So first one is static IP address, other one is called the dynamic IP address. So in the case of dynamic IP address every time change when you connect to the network. Next, question number 3 is a MAC address is made up of computer serial number and the IP address. No, that is false. And the last option is if a computer does not have an IP address, it cannot communicate with other devices using the internet. Yes, that is true. The table lists 5 devices. Tick to show if each device is an example of input device, an output device, or a storage device. So keyboard is an input device, microphone is an input device, headphone is an output device because it gives a sound. Hard disk is a storage device. It is used to store the data, and actuator is an output device. Okay, next question is what is the difference between the sample rate and the sample resolution? So here we have the definition of sample rate. Sample rate is the number of samples recorded in each second or in 1 second. Okay, so what is the sample resolution? Sample resolution is the number of bits that are used to record each sound sample. That's it. Let's move to the next question. 6 statements are given about methods of data transmission. Tick to show if each statement applies to serial simplex, parallel half duplex, or serial duplex data transmission. Some statements may apply to more than one data transmission method. So first statement is bits are transmitted along a single wire. So single wire is serial, right? So serial simplex and serial duplex. So we tick those 2 statements. Data is transmitted in both directions. So simplex and duplex and half duplex. In the duplex and half duplex, we can transmit data in both directions. So parallel half duplex and the serial duplex, we can take those 2. It is only suitable for distance less than 5 meters. So parallel data transmission is only suitable for distance less than 5 meters. So parallel simplex and parallel half duplex is the correct answer. Next one is bits from the same byte are transmitted one after the other. So bits are sent one after the other. So that is serial data transmission. So serial simplex and the serial duplex. Next one is data may not arrive in the correct sequence. So that is the parallel. So parallel simplex and parallel half duplex. Last option is data is transmitted in both directions, but only one direction at a time. So that is the half duplex. Okay, number 3. Tick to show whether an even or an odd parity check has been used for each binary value. Okay, so we have these binary values. We need to make sure that we need to check whether each binary value is using even or odd parity. Okay, so the last bit in the parity bit, okay, or the most significant bit is used as the parity bit. Okay, so these are the parity bits. So let's see. First we have the 7 1, and the parity bit is what is 1, so it means they're using the even. Here we have 2 and 4, 4 1, and the parity bit is 0, so it means they're also using the even parity. Next one, we have 2, 4, 6, 6. This is also the even parity. Let's see here, we have all 0 and the parity bit is 1, which means they're using the odd parity. Next question, complete and annotate the diagram to determine how packet switching is used to transmit data across the network, including the use of routers from a device A to device B. So in the packet switching, data is first broken down into small packets, okay? And then each packet is sent independently from device A to device B. And upon receiving on the device B, all the packet need to be reassembled, okay? So we have different routers here, okay? For example, this is R1, this is R2, okay, router 2, this is R3 or 4, for example, and this is R5 or 5. So each packet can take different routes. For example, first packet can go from R1, R4, and R5 to reach the destination. Second packet maybe can go from R2, R1, R4, R3, R5. Okay. Next packet maybe can go from R1 to R2 to R5. So that's how the packet switching works. Shia has 3 files stored on her computer. Tick one box to show which is the largest file size. So the correct answer from these two is 1 MB is the largest. Okay. Dennis has 3 files stored on her computer. Tick one box to show which is the smallest file size. So among these three, 2 GB is the smallest size. Okay, so draw a line from each term to its correct definition. So we have 3 terms. First one is the color depth, then we have resolution, and the last one is pixel. So what is a pixel? Pixel is a small square of a color that make up an image. So this is the correct for this one. Let's see the resolution. So resolution, the number of pixel in an image, that is called the resolution. Okay. And then we have the color depth. So color depth is the number of bits used to represent each color and in an image. So this is the correct answer. Next one, 4 7-bit binary values are being transmitted from one computer to another. An odd parity check is being used to check for errors in the binary values. Write the correct parity bit for each 7-bit binary values. Make sure it meets the odd parity. So we are using the odd parity and we need to make sure the number of ones in each byte are odd. Okay, so let's see the first byte. So 1, 2, we have 2. 2 is an even number, so the parity bit will be 1. Okay, next one, this is we have only 1. So we use the 0 as the parity bit. Then we have 2, 4, 6. We need to make it odd, so add 1. Then we have 1, 2, 3, and 4. So 4, we need to make it 5. So 5 is an odd number, so the parity bit will be 1. So this is these are the correct answer for this question. A printer is one example of an output device. Give 3 other examples of output devices. So it could be headphone, speakers, and projectors. Give 3 examples of input devices. Okay, so first device is microphone, keyboard, and mouse. Next question is, a system uses even parity. Write the appropriate parity bit for each byte. Okay, so we're using the even parity. Let's count the number of ones. So we need to make sure the number of ones are even in the byte. Okay, so 1, 2, 3, 4. So they are even. So we use 0 as parity bit. 1, 2, 3, 4, 5, 6. Again, even. Again, the parity bit will be 0. Let's count this one. 1, 2, and 3. So this is 3. So we need to make the number of ones even. So we'll use 1. So that's it. A computer can have both a media access control MAC address and an internet protocol or IP address. Give 2 similarities between MAC address and IP address. So the first similarity is they are both unique addresses. Okay, and the second similarity is they can both be used to identify a device on a network. Okay, so these are the 2 similarities. Part B, give 2 differences between a MAC address and an IP address. So the first difference is a MAC address is normally static, okay, whereas an IP address can be dynamic. So static means that a MAC address cannot be changed, but the IP address can be changed. Second difference, a MAC address is assigned by the manufacturer, okay, and whereas an IP address is assigned by the router or ISP. A computer is designed using von Neumann model for a computer system. The computer has a central processing unit or CPU. Data is fetched from the primary storage into the CPU to be processed Question number 1, state the name of primary storage where the data is fetched. So that is called the RAM, okay, RAM, random access memory. Second question, the CPU performs a cycle to process data. Fetch is the first stage in this cycle. State the name of the second and the third stage in the cycle. So the first stage is the fetch, then we have decode, and the last stage is execute. Okay. Third, identify two components within the CPU that are used in the fetch stage of the cycle. So the PC or program counter is the first component. Okay. Next one is MAR, like memory address register. So these are the components that can be that are used in the first stage. The CPU contains register and buses. Describe the role of a register in a CPU. So register is a type of secondary storage that is used to temporarily store data, instructions, and address. Okay. Next question is identify one bus that can be found in the CPU and explain the purpose in the fetch, decode, and execute cycle. So we know we have three buses inside the CPU. We have data bus, we have address bus, and we have control bus. Okay. So address bus is used to transmit address between the components in the CPU, while the data bus is used to transmit data between the components in the CPU, and control bus is used to transmit the control signals between the component in the CPU. Okay, so let's see the last question. Georgia is a wedding photographer. She wants to store 10 photographs on a USB flash memory drive for a customer. Each photograph is 100 pixel wide and 50 pixel high. The photographs are 8-bit color photographs. Calculate the file size in KB byte. Okay, for all the photographs. For this calculation, you may use the unit of measurement of 1024 or 1000. So we know calculating the file size is very easy. We just need to multiply all the numbers. So for example, first number is we know we have 10 photographs. So 10 multiplied by, then we have the resolution 100 pixel, 100 multiplied by 50. Okay, and then we have the color depth is 8-bit, right? Multiply 8, and we multiply all those numbers and we get this answer in the bits. The question is asking us to give the answer in KB bytes, so which means we need to convert this number, which is in bits, to KB bytes. So first let's convert this number to bytes, right? So how we convert this number to bytes? From bits to bytes, we just need to divide the number by 8, right? We divide the number by 8 and we got the byte. Now we need to convert these bytes to KB. Okay, KB bytes. So how we do that one? We just need to divide this number by 1024. So just divide the number by 1024 and we get this number, 48.83 KB bytes. So this is our answer, 48.83. Okay, so that's it. See you